in this problem, it says the scatter plots below show the relationship between height, diameter, and volume of a timber in 31 felled black cherry trees. The diameter of the tree is measured 4.5 feet above the ground. So we have this and this, these two scatter plots. So these are called scatter plots. So in other words, what's happening here? Let's take a look. So this graph right here is height versus volume. Notice. And this graph down here, whoops, is diameter versus volume. See the difference? They both have volume on the y-axis, the vertical axis, right? Up and down is volume, and sideways is height for this one, but diameter for that one. So that's what's different. So in other words, what are all these dots? So let's take a look at this, this dot right here. What does that dot mean? That means there was a tree that had a height of 65 whatever feet, and it had a volume of lumber that was 10 cubic feet of lumber, of timber, I guess they call it timber, in 31 felled black cherry trees. So in other words, what they're trying to do here is you've got some black cherry trees, and they're going out to the forest, the lumber company, and they're trying to figure out which ones should we cut down. We want to cut down the ones that are going to give us the most timber, right? The most volume of timber. Okay, well, there's two ways you can figure out which trees are going to give you the most timber. The trees that are taller, their height, or the trees that are diameter, thicker. Should you go with the taller trees or the thicker trees? Which one's better? Well, what they did is to figure this out, they made a big graph. And these dots, all these little dots, represent, so these are, notice there's 31 black cherry trees. And these dots, I'm just honing in on one dot. Each dot tells you how tall the tree was and how much timber it produced. So, so as you go to the right further and further, the tree was taller and taller. Like this tree right here was 85 feet tall, really tall. But the timber level, it's somewhere, I don't know what that is, maybe 30 cubic feet of timber. That's how much timber you got out of it. Whereas this one up here, he's like maybe 90 feet tall, and he produced a lot of timber, over 70 cubic feet of timber. So you see the dots. Now the other one, these are also 31. These are the same 31 trees. They just measured their heights here, and they measured their diameters of those same 31 trees on this graph. And so as you go to the right, you get trees that were thicker. They measured the diameter at 4.5 feet above the ground. So they went up 4.5 feet and then measured around the tree, the diameter, how far around the tree. Or no, I'm sorry, that's circumference. They measured across the tree. So if you got this tree, I don't know if you care about this much detail, then you go up 4.5 feet and you measure straight across at a height of 4.5 feet. You take a tape measure straight across. How thick is the tree at that point? So the diameter is the thickness. So notice trees that are like this dot here, this tree is pretty thick. It was like, I don't know, what, 18 or something. And how much timber? Looks like somewhere between 40 and 70, maybe 60 or 50, 55, whatever. And then this one up here was a really thick tree and a lot of timber. And this one was not a very thick tree and not very much timber. All right. So long story short, trees that are taller have more timber, and trees that are thicker diameter have more timber, of course. But the question is, which dot pattern is tighter? Well, clearly, this is a tight dots, close to a line. Whereas these ones up here, these are loose dots, not close to a line. So we're looking for a linear relationship. In other words, we're saying, hey, for taller trees, do we get more timber? Yeah, well, yeah, the dots go up to the right, but not very tight. It's not very predictable. Like you can have some trees like this one that's really tall, but look, his lumber's pretty low, right? And this one right here, he's not all that tall, but his lumber's really high. Whereas for the diameter, that's a better predictor. See, they're tight dots. So like it's all about the R value. If I was to guess, remember the R values we learned from the notes, right? Remember R is a number between -1 and +1. So this would have an R value. My guess would be something like 0.9, 0.90, probably about. I'm just guessing. Whereas this one would have an R value maybe 0.60. Again, it's about, I don't know exactly, right? Because in other words, a line would fit through here, through the middle. That'd be a line through the middle. And here would be a line through the middle of these dots, right? And remember the R value, R goes between negative, the closer R is to 1.0, like it's like a dollar. Think about it as money. This is 90 cents. This is 60 cents. R is a number that goes between, here's 0 in the middle. R is a number that goes between -1 and -1.000 and +1.00 with 0 in the middle. So R is somewhere in that zone. And if it's positive, the line goes up to the right. And if it's negative, it goes down to the right. This is the negative territory. This is the positive territory. So in this zone, R is positive, right? These are both positive. These are both positive numbers, right? Because the line goes up to the right, up. It doesn't go down, right? Neither of the dot patterns go down to the right. They both go up to the right. So it's positive, it's up, but the yellow one, is about right here, 0.60. And the green one is about right here, 0.90. It's closer to $1, right? It's a tighter dot pattern. This one is. This one right here is a tighter dot pattern, which means it's closer to forming a line, which means it's a tighter relationship, which means diameter is a better predictor of volume. Notice how thick the tree is does a better job of telling you how much lumber you're going to get from it. The height of the tree might tell you, but not as good. You can have some trees that are pretty tall, but they're really thin and there's not much lumber there. See, the dots are looser. So that's their questions. Let's go down and answer all their questions. Here we go. It says, describe the relationship between height and volume. Well, height and volume is this one. This is height and volume. Well, it's loose dots. It's loose. It's positive, but loose. So it is weak, positive. Whereas the second one, diameter and volume is the second one right here. Diameter and volume. That's tight dots close to the line. So that's a strong relationship, strong positive. So suppose you have to height the dimension of another block. So what should the lumber company use? Which of these variables would be preferable to predict volume? Well, diameter, right? That does a better job of predicting how much lumber you're going to get because the dots are closer together. There's a tight linear relationship, meaning the thicker the tree, you can count on getting more lumber from it. Whereas taller trees might give you more lumber, but sometimes it's way down here. It's kind of unpredictable. Sometimes they're way up here. It's just looser, more spread out. Doesn't do a good job predicting. Whereas diameter does a fabulous job predicting close, tight dots. So diameter is a better way to go. And so there we go.